Hello everybody. In the last couple of videos, we've been spending a lot of time understanding all the pieces of the hyperbola. I would say out of all four conics, by far the hyperbola is the most complex, but hopefully we'll see in this video, once we start working with the hyperbola, that all our hard work will finally pay off. Okay, the first thing we want to do in this video is I want you to pause the video and try to graph this hyperbola right here. Give it a shot. Okay. Let's do it. Okay. The first thing we want to think about is which way is this hyperbola oriented? Is it oriented left and right or up and down? We should notice, if we look out front, the variable that doesn't have the minus sign on it, this should have x-intercepts. So from here, we know that the graph should be opening up to the left and to the right. Okay, so we have the orientation down. Okay, so now what we should know is if we're trying to figure out the x-intercepts of this graph, well, this is a squared, so we have that a squared will be equal to 9, which tells us that a is going to be equal to 3. Okay, so we know where the vertices will be. The other thing we want to know is, I guess, this is going to tell us what our b value is. This will help us draw that central box so we can sketch the asymptotes. This says that b squared is 25, so we have that b will be equal to 5. Okay, so let's go ahead and sketch so far. Okay. So let's go ahead and plot the vertices. So we'll go to the right 3 units, and we'll go to the left 3 units. Okay, now for the central box, we'll want to go up 5 and down 5. And now we'll draw the central box. Once we have this central box, we can now, really we can sketch everything. Okay, so what we know is that the asymptotes of the hyperbola hit the corners of the central box. So let's sketch the asymptotes. Okay, here they are. Okay, now since the vertices are at 3 and -3, or if they're points, they're at the coordinates 3, 0 and -3, 0. Okay, we know the graph will touch these points. So the graph will touch here, and it'll start to approach these asymptotes. Okay. So here we have it. This is a graph of the hyperbola. Now, there's a couple other features that we're going to want to know. Okay. We're going to want to know the equation of the asymptotes, and we're also going to want to, I guess, record the vertices and also record the coordinates of the foci. Okay, well, I think we can hopefully easily write down at least the equations of the asymptotes. Okay, so for this one right here, maybe I'll sketch the asymptotes. I don't know, how about we sketch them in red? Here's another one. Okay, so these lines have the equations of these lines have a y-intercept at 0, so they'll be of the form y equals mx, where m will be the slope. So we'll have y is equal to, well, our rise is 5 and our run is 3, so this will be 5/3 x. Okay, that's one of the asymptotes. For this one right here, it'll have the same slope, except it'll be negative. So this one will have an equation, y equals -5/3 x. So those are the equations of the asymptotes. Okay, let's try to figure out the equation. I guess we could also write down the coordinates of the vertices. Okay, so maybe I'll call this one, I don't know, we'll call this vertice 1. We'll call this vertice 2. So vertice 1 has coordinates -3, 0, and vertice 2 has coordinates 3, 0. Okay. Now for the foci, there's a formula for the foci, and just like with the ellipse, there's this right triangle I remember that helps me find the formula for the foci. We'll want to be thinking about this right triangle right here. Okay. The distance from here to here is what we call A. I should maybe draw this a little bit higher. Okay. This here will be B, and this will be C. Okay. So if we lay this hypotenuse right here down, this tip here will hit our foci. So using the Pythagorean theorem, we have that C squared will be equal to A squared plus B squared. Okay, so let's figure out what C needs to be. Okay, well, A squared is 9. So we'll have C squared will be equal to 9. Or sorry, A squared will be equal to 9, so C squared will equal to 9 plus B squared is 25. Okay, so we have that C squared will be equal to 25 plus 9, which will be what, 34. Okay, so C is going to be equal to the square root of 34. Let's see what that roughly is. Grab my calculator. The square root of 34 is roughly 5. So this is roughly 5.8. Say 3, 1. So this is 3, 4, 5, 6. So here's 6, here's 5, here's 4. So one of the foci will be relatively 5.8. So right here, how about I call this focus 2? This will have coordinates, the square root of 34 and 0. And the other foci will go backwards. -6, -5, -4. This is where, I guess, foci 1 will be, and it'll have coordinates negative the square root of 34 and 0. Okay. So maybe I'll write all this information right here. Okay. We have the graph, we have our vertices, we have our foci are at negative square root of 34 and 0. We have the other foci is at square root of 34 and 0. And the equations of the asymptotes will be plus or minus 5/3 x. Okay, so here we have it. Awesome. Okay, let's do another one. Okay, let's graph. How about y squared over 16 minus x squared over 4 is equal to 1. Go ahead and pause the video and give a shot at graphing this hyperbola here. Also, tell me the coordinates of the vertices, tell me the coordinates of the foci, and tell me the equation of the asymptotes. Okay, let's do it. The first thing to think about is the orientation. This one here will have y-intercepts. Y-intercepts. Okay, so in this case, a squared will be equal to 16. And here we'll have that b squared is equal to 4. So we have that a will be 4 and b will be 2. Now we can sketch that central box. We'll have the pretty much have the general sketch of our hyperbola. Now we'll just have to label kind of some of the key features of it. Okay, A. So in this case, this is telling me where the y-intercepts are, so I need to go up 4. And right 2 and left 2. So we'll draw our central box. Okay. And now the asymptotes will pass through the corners of the central box. Okay. Okay. The y-intercepts will be at, in this case, 0, 4 and negative 4, 0. Okay, so we can write that down right now. So we have, I don't know, let's call this one, I don't know, we could call this one vertice 1, or just one of the vertices will be at 0, 4, and the other one will be at 0, negative 4. One of the most common mistakes I see that students make when they're graphing hyperbola is they want to draw the hyperbola kind of going in to the central box, but no part of the graph will ever be inside of the central box. It'll always just hit the central box, I guess, at 2 different points here. Remember, part of the central box tells us where the vertices of the hyperbola are. Okay? So let's now find the equations of the slant asymptotes. Okay, so let's see here. Maybe in red again. Okay, the equation of this asymptote, the positive asymptote, well, the rise is 4 and the run is 2. So this will be 4 over 2x, or we could just say 2x. This one here will be y equals, it'll be the same slope, just negative. It'll be a negative 4 over 2x, or y will be equal to negative 2x. Okay, so we have the 2 slant asymptotes. Okay, now we just need to find the foci. What I like to do is just remember this right triangle right here. Okay, so from here to here will be our A. From here to here will be our B. This will be our C. So we have that, let's write it over here. We have that C squared, a different color. I'll keep it in blue. We'll have that C squared will be equal to A squared plus B squared. So here, C squared, well, our A squared is 16. Our B squared is 4. So we'll have that C squared will be equal to 20, or C will be the square root of 20. Okay. I guess if you want, you could clean up this root. I guess you could write it as what? 20 is 4 times 5, so it'll be the square root of 4 times the square root of 5. Square root of 4 is 2. So it's the same thing as 2 root 5 if you'd like. So let's see what that roughly is. So roughly 4, this is roughly 4.472. So here's 5. This will be what? Almost 4.5. So maybe roughly right here. So I don't know, what do we call this one? We called this one vertice 1, so how would I call this? This will be where the first focus is. And this is where the second focus will be. This is what I called the vertice 2. This will be focus 2. And what will be the coordinates of those focuses, or those foci? Okay. This one will have coordinates, let's see, 0 and 2 root 5. And the other one, this foci, will have coordinates 0 and negative 2 root 5. Okay, I would have no problem if you left 2 root 5 as root 20. Okay, and the equations of the asymptotes will be y equals plus or minus 2. Okay, here's the graph, and here's all the other information we should know about the hyperbola. So the key thing is really once we have that central box, the central box really guides the entire rest of the problem. Let's go ahead and try this next problem. Given the graph of this hyperbola, I want you to try to find its equation. Go ahead and pause the video and give it a shot. Okay, let's do it together. The first thing I think we want to ask ourselves is, what is the orientation of this parabola? Or which version of the equation do we have? Well, it's good to notice here that this hyperbola, well, its center, which is the intersection of these two slant asymptotes, will be at the origin. So its x-intercepts will be at 2 and -2, or it has x-intercepts. So the equation will be x squared over a squared minus a y squared over b squared will be equal to 1. Okay. So let's try to figure out the distance from the center to one of the vertices. That'll tell us the a value. So from the center to this vertice, well, this distance is 2, so this says that a is 2. So we have that a will be equal to 2. Okay. So what we could do from here is, I guess if you were looking at a graph, you could try to think about what the central box would be. And while this is a hand-drawn graph, it's of course not perfect, but this would be what I at least intended for the central box to be. So you could look and see if we went over 2 to get back to the line, we would have to go up 3. So here B would be 3. Okay. But since this was a hand-drawn graph, it might have been hard to see that if we went over 2, we would go up 3. So we could equivalently have used this point here to help us. Now, in general, usually problems won't give you a point on one of the slant asymptotes. In this case, because it was a hand-drawn graph, I just wanted to make it clear about one of the points. But if it's a problem, if a problem from a textbook, you would want to look at the slant asymptote, and you would want to try to find a point on the slant asymptote. So you could have said, well, what's the equation of this slant asymptote? Well, it'd be y equals, okay, it has a y-intercept at 0. What's the slope? Well, if we go over 4, we go up 6, so the rise is 6, and the run would be 4. Or we'd have that y would be equal to 3 halves x. So in this case, we would have 3 over 2. Remember that the equation of the slant asymptotes in this case would be b over a. So this would be equal to b over a. In this case, we knew that a was 2, so we could fill that in. So we'd have 3 over 2 would be equal to b over 2. You could multiply both sides by 2 and get that b. B would be equal to 3. But either way, the equation will be x squared all over. Our a was 2. If we square that, we'll get 4 minus a y squared. Let's see, our b is 3. B squared, or 3 squared will be 9, will be equal to 1. So this is the equation of this hyperbola. One thing to notice that we need to be careful about that's different from a hyperbola to an ellipse is these a's and b's. For an ellipse, a is always bigger than b. That's how a is defined on the ellipse. A is the distance, I guess, from the origin to one of its vertices, or it's the distance from its origin, I guess, to the end point of the major axis. For ellipses, a is always bigger than b. That's not always the case for hyperbola. A and b, one could be bigger than the other. It really depends. Like, I could have taken this graph and I could have had it be facing up and down. In that case, a would be 3 and b would be 2. So it's not true in general for hyperbola that a will always be bigger than b. And we'll want to make sure to remember that. Let's try this next example. I want you to pause the video and try to find the equation of a hyperbola that have foci at 0 plus or minus 10 and vertices at 0 plus or minus 8. Give it a shot. Okay, let's do it together. So I think what's going to help us first is to plot these points. We'll plot them right here. Okay, so our foci are 10 units up. Maybe I'll just mark a 10 here. 10 down. And we can mark an 8 and a -8. Okay, this will be foci. I should mark a -10 here. These are where the foci will be. And the vertices are at 8 and -8, so I don't necessarily know the equation of the slant asymptotes, but since these are where the vertices are, it's going to be opening up and down. So it'll look something like this. So right off the bat, we know that this will have a general form of y squared over a squared minus an x squared over b squared will be equal to 1. Okay, we just need to figure out what our a's and our b's are. Well, what do we know? Well, we know the distance from the center to one of the vertices. Well, this is 8, so we have that a will be 8. And we also know the distance from the center, I guess in this case it's the origin, to one of the foci. This is telling us that C is 10. Okay, so we know what A is, but now we need to figure out what B is. And how are we going to do that? Well, we need to remember that Pythagorean identity for hyperbola. In that case, we should remember, you could draw the picture if you like, but we should have that C squared should be equal to B squared plus A squared. Okay, in this case, I guess we could solve for B squared. So here we would have that b squared would then be equal to c squared minus a squared. Okay, well c is 10, so c squared will be 100. Okay, a is 8, so a squared will be 64. So we have that b squared will be equal to, what will this be? I think 36. Okay, this tells us that b will be 6, but we don't really care what the b value is if we're just trying to find the equation. We just need to know what b squared is. B squared is 36. So here our answer will be y squared. Let's see, a is 8, a squared is 64, minus x squared over b squared. B squared is 36. That'll be equal to 1. And that's our answer. Let's try this next example. Go ahead and pause the video and try to find the equation of a hyperbola that has its vertices at plus or minus 6 and 0 and asymptotes at y equals plus or minus 2/3 x. Give it a shot. Okay, let's do it. The first thing to notice is that its vertices are along the x-axis. So here we go out 6 units to the right, 6 units to the left. So the hyperbola will be opening up to the left and right. Okay, so this tells us that the general equation of this hyperbola will be x squared over a squared minus y squared over b squared will be equal to 1. Okay, well, we already know what a is. So here we have that a will be equal to 6. And now we need to think about what b is. Well, we haven't used the information about the asymptotes. So in this case, we need to remember that the asymptotes, at least for this version, if we were to think about the asymptotes, if we were kind of to draw a general sketch of them. So this isn't the general sketch of this hyperbola, just some information to give us an idea. Okay, well, this distance is what we call a, so a is 6, and this distance right here will be b. Okay, so the asymptotes for this hyperbola will be y is equal to plus or minus, well, rise over run, b over a, x. Okay, in this case, we have that b over a should be equal to 2/3. We're just kind of matching up these slopes here. Okay. One of the most common mistakes I see students make is to say, well, b must be 2 and a must be 3. That's actually not the case. It may be true in some examples, but it won't be true in general. And actually, we can see in this case that it's not true that a is 3, because a is 6 here. We have to be careful because this is most likely a reduced fraction. So since we know a, we just need to throw that into the equation. So here we'll have b, our a is 6, will be equal to 2/3, and now we'll solve for b by multiplying both sides by 6. Okay, so let's see what we're going to get. The 6's cancel. So we have that b will be equal to, let's see, the 6 and the 3. Let's see, this will cancel and make the 6 a 2. 2 times 2 will be 4. So b will be 4. Okay, so notice here that A is 6 and B is 4. So if we do B over A, B is 4, A is 6. This reduces to 2/3, which is the slope that we were given. So putting everything together, we have that the equation will be x squared. Let's see, A is 6, so 6 squared will be 36 minus y squared. Let's see, our b was 4, so 4 squared will be 16, and that'll be equal to 1. Here is the answer to the equation. Let's try this next problem. I want you to try to find the equation of a hyperbola with vertices at 0, plus or minus 5, and goes through the point 11, 6. Give it a shot. Okay, let's do it together. The first thing we should look at is the orientation. So the vertices at 0 plus or minus 5, so they are along the y-axis. So the hyperbola will be opening up and down. Okay, so the equation will be y squared over a squared minus x squared over b squared will be equal to 1. Okay, let's go ahead and erase this picture. Okay, well, so far, we know that A will be 5. So that's what this is kind of telling us. I know I erased the picture, but A will be 5. So we have that y squared over, let's see, what's 5 squared? 5 squared will be 25. Minus x squared over b squared will be equal to 1. So really our job is to try to figure out what b is. Well, the only other piece of information we haven't used is that we know a point on the hyperbola. So we want to find the value of b such that this is a point on the hyperbola. Basically what we're going to do is we're going to plug in x, we're going to replace x with 11 and y with 6, and we're going to solve for b. Okay, let's do it. So we will write, let's see, our y is 6, so we'll have a 6 squared over 25 minus x squared, or in this case 11 squared, over b squared will be equal to 1. So we substituted in 11 for x, and 6 for y. So it looks like we're going to get 36 over 25 minus 11 squared is 121 over b squared will be equal to 1. So our job here is to solve for b. Okay, so how are we going to do that? Well, I guess there's a couple ways we could do this. If we wanted to, we could clear the fractions. But what I'm going to do instead is I'm actually going to subtract 36 25ths from both sides. So we'll get a negative 121 over b squared will be equal to 1 minus 36 over 25. This problem shouldn't be terrible to deal with in terms of fractions. Okay, so what are we going to get? So instead of a 1, let's write that as a 25 over 25. So we have a negative 121 over b squared. This will be 25 over 25 minus 36 over 25. Okay, so we'll have a negative 121 over b squared will be equal to, let's see, 25 minus 36 is, that'll be negative 11. So negative 11 over 25. From here, I think what I'm going to do is I can just reciprocate both sides of the equation. So this would be the same thing as saying that negative. I guess you could also multiply both sides by a negative if you wanted to. And that'll get rid of the negatives. So you'll have a 121 over b squared will be equal to 11 over 25. We can reciprocate both sides. So b squared over 121 will be equal to 25 over 11. Okay, let's multiply both sides by 121. Okay, bring our work up over here. Okay, so we're going to now have that b squared is going to be equal to, well, 121 is the same thing as 11 squared. So this will cancel, and I'll just get out an 11. So we'll have 25 times 11. Let's see, 25 times 10 is 250, plus another 25, so we'll get 275. So here we have that b squared is equal to 275. You could square root both sides if you'd like to figure out what b is, but we don't really need to know what b is. We just need to know what b squared is. So we have that y squared over a squared minus x squared over b squared will be equal to 1. B squared is 275. So x squared over 275. And our a was 5, so a squared will be 25. So we'll have y squared over 25, and here is our answer. Let's now get some practice with shifted hyperbola. I want you to pause the video. I want you to sketch a graph of this hyperbola. I want you to find the coordinates of the foci, the coordinates of the vertices, and the equation of the asymptotes. Give it a shot. Okay, let's do it together. The first thing we're going to want to think about is we're going to want to think about where the center has been shifted. Okay. So here, we should notice that the hyperbola has been shifted. In this case, it will be shifted up 2 units. And here, this will be telling us that the hyperbola has been shifted, looks like, to the left 3 units. So our center, in this case, maybe I'll record that over here. Give ourselves some room. The center will be at -3 and 2. So now once we find our A's and our B's, we're going to make all those measurements from our new center. Okay, let's do it. Okay. -3, 2. Okay, here's our center. We know that the asymptotes will intersect at this point. Okay, so in this case here, if it was unshifted, if I cover up the -2 and the 3, if it was unshifted, this graph would have y-intercepts. Now that it's moved, it'll most likely have both x and y-intercepts, but at least this should tell you that it's facing up and down. Okay, so that tells us, maybe a different color, tells us here that a squared will be 9, or our a will be 3. This here tells us that our b squared will be 16, or that our b will be 4. Okay, since it's facing up and down, we'll go up 3 units and down 3 units from our center. So going up 3 units, 2, so we'll be at 5. And now we'll go down 3 units. We'll be at -1. Okay, so this will be the coordinates of one of our vertices, and this will be the coordinates of the other one. Okay, so I don't know, it doesn't really matter how we label these. Let's call this V1. So one of our vertices will be at coordinates -3, 5. Okay, and this vertice here, I don't know, we'll call it V2, will be at -3, -1. Okay. Now let's find or move our B value so we can draw our central box. So we're going to want to go right and left 4 units from our center. So going right 4 units, I think will put us at 1. Going left 4 units, here we'll be at -7. So here we have our central box. Okay, we can draw our asymptotes. Let's do that a little bit better. Okay. And since it's opening up and down, the hyperbola will look something like this. Okay. Let's now write down the foci. So we need to figure out what C is. Okay, we should remember that C squared is equal to B squared plus A squared for hyperbola. Our B squared is 16. So we'll have that C squared will be equal to 16 plus A squared, which is 9. So we'll have that our C squared is equal to 25, which tells us that our C is 5. So we'll go up 5 units from the center. So let's see, 1, 2, 3, 4, 5. So here we are at 7. Here's one of our foci. And the other one, let's see, 1, 2, 3, 4, 5. So at -2, this will be at -3. Here's our other foci. Let's write those down. I think I called this one vertice 1, so we'll call this focus 1. Let's erase a little bit of this here. So foci 1 will have coordinates what? -3, 7. And foci 2 will be at what? -3, -3. Awesome. Okay, now let's try to find the equation of the two asymptotes. Okay, there's a couple ways you could do this. I guess one way that we could do this is, well, we could think about the slope, or we could find the equation of these asymptotes if they were not shifted. So if they weren't shifted, let's see here, what would be the rise and the run? Well, let's see, this is our A value, this is our B value, so we would rise 3 and run 4. I'm actually going to erase a little bit of this so I can have a little bit more room. But maybe I'll just write this right here for your notes. So notice from here, we would run 4 units and we would rise 3 units. So we know the slope of this line here will be 3/4. The slope of this line will be -3/4. Okay, I'll give you a couple different ways to find the equation of these asymptotes. If they are unshifted, the equation would be y equals plus or minus, okay, our rise is 3, our run is 4. And now we're just going to shift them. So since we shifted it up 2 units, I'm going to replace y with y minus 2. So now when they're shifted, we'll have y minus 2 will be equal to plus or minus 3/4, and we'll replace the x with an x plus 3 since it was shifted left 3 units. Okay. In some situations, this is all you would need to do. You would just, you would write, I don't know, to give ourselves a little bit more room here. In some situations, just writing that the asymptotes would be y minus 2 would be equal to 3/4 times x plus 3, and also y minus 2 being equal to -3/4 x plus 3. Sometimes this would be fine for the answer, but in the case where it maybe wants us to put it in the y equals mx plus b form, we would just need to distribute and do, looks like a little bit of fraction addition. So let's do that. Let's distribute in the 3/4. Maybe we'll do both these at the same time. Here we'll distribute in a -3/4. So we're going to get y minus 2 will be equal to 3/4 x. 3/4 times 3 will be 9/4. Okay, over here we'll get y minus 2 will be equal to -3/4 x and then minus 9/4. Okay, looks like we'll just add 2 to both sides. Okay, so we'll get a y will be equal to 3/4 x plus 9/4 plus 2. Over here we'll get y will be equal to -3/4 x, let's see, what, minus, give ourselves a little bit more room. Y will be equal to -3/4 x minus 9/4 plus 2. Okay, how about instead of a 2, we write this 2 as what? That'll be the same thing as 8/4. So we have a common denominator, so let's write that as 8/4. This 2 will also write as 8/4. Okay, so we'll have y will be equal to 3/4 x. Let's see, 9 plus 8 will be 17, so plus 17/4. Over here we'll get y will be equal to negative 3/4 x. Let's see, negative 9 plus 8, that'll be negative 1 or negative 1/4. So here are the equations of the asymptotes. Now I guess it depends on what the problem is asking. Sometimes this might be sufficient for your answer, but if they want it in the form y equals mx plus b, you'll need to solve for y, which we've done here. Okay, just a quick tip on maybe a different way you could have done this problem. So, we know the general equation of a line is y equals mx plus b. Maybe I'll just do this for maybe the positive version. Maybe you could take a look and try it for the negative one. But we knew the slope, at least for the positive version, was what, 3/4? So we have y would be equal to, we'll replace our m with that, 3/4 x plus b. And now we just need to figure out what our b is. So we just need another point on the line. But remember, the center of a hyperbola is a location where the two asymptotes intersect. So we know that the center is a point on the line. Or at least this will be a point on the asymptote. So what we could do is we could just plug in those x and y values and figure out what value of b would force this to be a point on that line. So let's do that. So our y would be 2, so let's replace y with 2. And our x is negative 3 plus b, so 2 would be equal to, what that'd be, negative 9/4 plus b. Okay, we could add 9/4 to both sides, so b would be equal to 2 plus 9/4, or we'd have that b would be equal to, looks like 8/4 plus 9/4, which is 17/4. So now we know what the m is, we know what the b is, so here the equation would be y equals 3/4 x plus 17/4. Maybe a good exercise is repeat this exercise and try to find the equation of the negative one. Here we would just have a negative 3/4 instead, but we know this would also be a point on the same asymptote. Let's try this next example. I want you to try to find the equation of a hyperbola that have vertices at 6, 2 and 2, 2 and foci at 1, 2 and 7, 2. Pause the video, give it a shot. Okay, let's do it together. I think what might help us here is to sketch these points so at least we get an idea of the orientation. Okay, so the vertices are at 6, 2. Let's actually do this. All these numbers are positive, so all these features are going to live in the first quadrant. Okay, so 6. Let's say 6 and 2. Let's see what 2 and 2. So these are the vertices. And the foci are at 1 and 2. And 7 and 2. Okay. So just from here, we should see, I mean, these here are the vertices, so maybe I should write that. This here is V, this one's V2, this one is V1, this would be focus 2, and this one would be focus 1. Okay, so the hyperbola is going to do something like this. Okay, so what we need to do is we need to figure out the center. At least from this graph, we might be able to reason that the center should be at, what, 4 and 2? This is where the center should be. But let's say you didn't draw the graph. We could actually figure out where the center is by finding averages. So I want to know, or at least we know that the center is halfway between the vertices, or the center would be halfway between the two foci. So we could either average 2 and 6, or we could average, what, 1 and 7. Either way, we should get out 4. So if we take 2 plus 6, and we average those numbers, but we're going to get 8 over 2, so that'll give us 4. Or even if we did with the 7 and the 1, 1 plus 7, let's average those numbers, we're still going to get 8 over 2, which is 4. So we know the x-coordinate is 4 and the y-coordinate is 2. So a key thing here is that we know that the center is at, what, 4 and 2. Okay. We could also now figure out what the C and the A values will be. Okay. So the distance from here to here, from the center to one of the vertices, will be our A value. And it looks like we're going from 4 to 6, or this will be 2. So our A will be 2. Or I guess what you could have done is taken this vertice and subtracted their x-coordinates to get 2. We have A is 2. And what will our C be? Looks like our C is going to be 3 here. Our C will be 3, or you could take one of our foci. Here, 7 minus 4 will be 3. Okay, we should also notice that it's opening up to the left and to the right. So we are going to have an equation that's of the form. I'm going to erase a little bit of this here. Let's actually write down what we know. We know that A is 2 and our C is 3. So since it's opening up left and right, we should have an x minus h squared over a squared minus a y minus k squared over b squared will be equal to 1. Okay. Well, the center, this will be our h, this will be our k, or you could think that we are shifting it to the right 4 units, so we should have a x minus 4. And we're shifting it up 2 units, so we should have a y minus 2 squared. Okay, we already know what our a is. Our a is 2, so a squared will be 4. In this case, a is 2, so 2 squared will be 4. Okay, we need to figure out what b is, so we'll need to use that Pythagorean identity. So we know that c squared is equal to b squared plus a squared. Again, if you forget this, I would recommend drawing the picture. Okay, so we need to figure out what b is. So here we'll have that b squared will be equal to c squared minus a squared. So b squared, let's see, our c was 3, so c squared is 9. Our a is 2, so 2 squared is 4. So we'll have that b squared will be equal to 5. So b will be root 5, but really we just want b squared. So this will be all over 5, and that'll be equal to 1. And here we have it. Here is the equation. Here's the equation of this hyperbola. I think that's all the examples, or all the, I think we finished everything we need to do with all 4 conics. What we're going to do in the next video is we're going to look at general conics. We'll see you there. Take care.